Okay, what we're going to start talking about is a topic called problem solving. Problem solving is extremely important in every facet of your life. It's something. It's a skill that we work on in mathematics quite often. Problem solving is basically just solving a problem or figuring out how to solve a problem when the normal way of doing that problem is not available to you. So, for instance, we talked about area the other day, and we found the area of a triangle. Well, the formula that most people know for the area of a triangle looks something like this. You can write it in two forms: 1/2 times base times the height, or you can write it like this: base times the height divided by 2. Those are the two most common ways that you'll see it. Either one is fine. They both mean the exact same thing. So in order to do this problem, you need the base, the length, the measurement of the base. It can be in whatever the units are, so 30 inches, let's say. So we have a triangle that's 30 inches wide at the base. And then if you go straight up to the top has a certain height. Now, the way you measure the height is straight down and make a 90-degree, that makes a 90-degree angle with the base. And if we know what the height is, let's say the height is 10 inches. Well, we have these formulas. You can take either one, plug it in, use the one that you feel most comfortable with. And so the base is 30 inches. The height is 10 inches. And then we divide that by 2. 30 times 10 is 300, divided by 2, you get 150. Don't forget that you're multiplying these as well, so the units become square inches. So 150 square inches. So that's how you solve or find the area of a triangle if you know the base and the height. Well, the other day we did a problem that was a little different. We had something where we knew the angle, let's say 50-degree angle. We knew the base, it could be, 60. We call that 60 feet. It could be a piece of a triangular piece of property, land. So, and then we don't know the height though. And so instead of the height, what we know is this side length here. So the side length is that line between these two angles, or the line segments. So let's say this is 40 feet. So our problem is we have this tool over here, which we can write this way, but we're missing a part. We're missing the height. If we had the height, then it would work perfectly. So we can't do that, so we can't use the normal strategy of just plugging it in. So what we need to do is look at our information, think about what we know. One of the things is the area formula. Even though this area formula doesn't work here, we need to make sure we remember it, because maybe we can make it work somehow. Maybe we can change something a little bit. So what do we know? We know the measurements. We know the area formula. We've also been working on trig, right? So we have SOHCAHTOA. Now, SOHCAHTOA, trigonometry, right? Sine, cosine, tangent, those work with right triangles. This is not a right triangle. So this doesn't quite work either. So we have to figure out, we have to change, like I said, we have to change things. We have to see what we can do to modify one or both of these to see how we can figure out what the height is. So that's what we need to know right here, is what is the height. So now when I draw that line down here, notice it wasn't there before, but now we have a right angle. So this part, if you cover up the other part of the triangle, now we've changed the triangle a little bit. We've kept some parts, right? This side is still 40. when we do this, we cut this, it's no longer 60. We don't know what this is, this part of it is now. And then we have a 50-degree angle. So if we redraw this, this is what we have. We have 40 feet here, 50 degrees here. We don't know what's down here, and we don't even care. What we're looking for is this right here. We want to know how high it is. So what is the height? Now remember, when we use H here, it can be a little confusing because it's not, H stands for height. It doesn't stand for hypotenuse. So that's why I wrote the whole thing in. Hypotenuse is still directly across from the 90-degree angle. Our hypotenuse is 40 feet. So you want to look at this angle, just like we did before, and ask yourself, what do we have? Well, that's our opposite side. That's our hypotenuse. And so we have OH. Now these others have OH. So what we're looking at is the sine. So the sine of 50 degrees is going to be equal to our opposite side, which is our height, divided by 40 feet. So now you multiply both sides by 40 feet. And that's nice because now they cancel out, and we're left with height is equal to 40 feet times 50 degrees. And the next step is just to use your calculator to find the height. And we get 40 times the sine of 50 equals, and that gives us our height of 30.64, which is approximately 30.6 feet. Okay, there we are. So that's our height. Now we've done a little bit of work to get there, but we're not done. But now we have the height, which was our only missing piece up here. So we can use this now with the original triangle base, plug it back in, and we have the area equals the base, which is 60 feet, times 30.6 feet, excuse me, divided by 2. So we multiply that out. 30.6 times 60 divided by 2, and we end up with 918. And remember, we multiplied feet times feet, so that's square feet. And that's how you find the area. Okay, so that's what that is problem solving. It's thinking outside the box a little bit. Now, if you've heard that term before, it's finding a different way of approaching a problem because the method you have right now doesn't work or isn't working. So let's look at another situation. It may not seem the same way. It may not seem the same in any way, but it actually is. So what we have here is a flagpole. And I know we haven't been outside for a while, but it's a sunny day. And if you've been walking around ever in your life, and I'm sure you have, you've noticed that when the sun is out, if you look down, there will be a shadow. And that's what we will have here as well. Now, let's say we need to find out how long this flagpole is, how tall it is. Well, there are different ways we could do that. We could go up to the top and measure it, but let's just say that we really don't want to climb that flagpole. And we want to stay on the ground somehow and get a good idea of how tall it is. So this is how you go about doing it. Think about you got to think outside the box. What do we know? Well, we have our trigonometric ratios, so katoa. Okay, we have a flagpole. We have sun. Okay, it doesn't seem like we can, and there's no triangles here, right? So you have to kind of think outside your box, outside the box. What do we have? Well, look here. Down here, there's a shadow. Okay, so now if you ignore the flag itself, okay, you have the flagpole. The shadows down here. There's your flagpole. Okay, down here, that makes a 90-degree angle. Okay. Trig works with triangles. It doesn't work with L's. So we're missing something, aren't we? What are we missing? We're missing the side that would be across from this. We're missing the hypotenuse. Okay, so what we want to know is what's the height? So we don't know that side. What about the shadow? Can we measure that? Okay. And the answer is yes. That's relatively easy to measure. We can, with a long measuring tape, or there's different ways you can measure the length of the shadow when you're on the ground. And so that's what we're going to do. We're going to measure the length of this. Let's say the shadow is 32 feet. Now, what else can we use? What do we need? Now, in SOHCAHTOA, right, or what are we talking about? We have the sine of some angle, alpha, is equal to the opposite over the, oops, I started to write the wrong one, opposite over the hypotenuse. Okay, well, what do we have? Two sides and an angle. Oops. So in this triangle, we have one side, another side we're trying to find. So we and what else do we need? So one of the sides is going straight up and down. What angle do we want to talk about? We've got three different angles, right? That's our 90-degree angle. In trig, we're not going to be using a 90-degree angle. We're going to be using these other two angles. So we've got two to choose from. Since we're standing on the ground, I think this angle right here would be the one to use. Okay, so we have an angle, but we have a problem. Right now, we don't know it. Okay, we have a side. It's the adjacent angle, 32 feet. And then the opposite side, we need to find. So if we plug it in right now, what we have right now is the sine of alpha equals the opposite. I'm just going to write it out completely. Instead of writing h, I'll write height divided by 32 feet. Now, in order to figure out how tall this is, we need alpha. We need the angle. Well, fortunately, we're on the ground and we can measure that. So basically what you do is you stand on the end of the shadow, you look up towards the end of the flagpole, and you check the angle, you measure it. You can use, it's very simple to make a measuring device for that. It can be very simple or more complex and more accurate. But if you have a horizontal stick and then you raise it up so that it points towards the top of the flagpole. So we're down here, we raise it up to the top of the flagpole, then you use some sort of a protractor and you measure your angle. So the point is you can measure that angle. And let's say we measure the angle and it's 70 degrees. Now you plug it in, sine 70 is the height divided by 32. And you multiply, and that's 32 feet. You multiply by 32 feet, both sides. That cancels, and your answer is going to be 32 times sine of 70. So with these numbers, this will cancel, and you get the height of that flagpole equal 30.07. So we'll round that off. It's about 30 feet tall. So that's how you can measure something without having to climb all the way to the top. Now, you might run out of jobs if all you have to do is measure flagpoles, but there are other things that they need to have measured as well. There's a branch of, there's something called surveying, which is measuring land. How you ever wonder how they measure the height of a mountain? Well, that's one way you could do it, by making measurements and trigonometry. That's how it's done.